Good morning. Okay, our next topic is in linear data structures implementation using stack. Linear data structures implementation using stack. So here linear data structure implementation using stack means here stack nothing but it is a linear data structure. In a previous class we discussed arrays. Arrays also an example of a linear data structure. Here stack is also an example of linear data structure. Okay, that we say here stack is a linear data structure. Stack is a linear data structure, but what it will do means with the right here it follows. Then take next point. It follows some rule. Follows a specific rule. Specific rule. That is, so stack means it is a linear data structure. So by following a rule, we should implement this stack. Okay, so that what is that rule? Just we can write here. Like stacks are special data structure just a minute. Just watching video. Stacks are special data structures where insert and delete operations are performed only at a specific end. Specific end. That means in array we have two ends where I will show in a point. See, right? So if you think if this is an array, this is an array. In this we can store the elements in these blocks. We can store the elements in these blocks. That means this is the 0th index, so first index, it is a second index. Like that the indices will increase. So where this 0 index is coming, we can call this is a front end. This is a front end. Front. Okay, so now when we insert an element in this, if I insert 50, then this index will be increase. Index will be increased. So before I entering the element, the stack will be like this. See, first of all, the stack, just we can think this is a stack. Okay, like this. So before I entering, it is the front. Just it is a front. Can say this is a front. So try to understand clearly. And no elements are there in this array or stack. No elements are there in this. Okay, now so no elements are there means end is also this one. Front this is and end is also same thing. It is end, it is a front both. So when I insert the element, into this, then I can insert here 50. Then what will be happen? The stack it creates one more block. one more block. So now front will not change, but what is the end here? This is the end. This is the end. Okay, na? This we can call, this is the rear part. This is the front part. This is the rear part or back part. Okay, right. So we can say this is end. End will be increased. Okay, so here end will not. So when we insert the element, then end will be increased. If I insert the element here also, if I insert the element here also 60, then end, then stack or array creates one more block, then the end will come here. End will be this is. That means this is a rare or end we call. Okay, rare part. Okay, so where we are inserting the elements at the end point, at the end point, so end is increasing, that here we call a top also, top or front. Okay, so we can call end, top, rear, all these are the similar words. Here at the top we are inserting the element. For example, if I insert the element here, then the top will be increased, then top will be increased one more. Now the top, so here I can insert the elements, again top will be increased, like that. That means it is following a rule. Always we are inserting the element at the top. So if you want to remove the element, if we want to remove the element, so we need to remove that from the top only. In that way we should write the program, we should implement that linear data structure. That means from the top only we have to remove the element. But we can remove, if it is array, we can remove this element or this element, any element we can remove if it is the array. But when we are implementing the stack, we should not do like that. Okay, we have to remove from the top only. In that way we have to write the program. Okay, this is known as a stack. That means what a stack is doing, when we are inserting the elements, we have to insert from the top. If you want to delete the elements, so we have to delete from the top only. That means we are inserting the elements from here. So which element we are inserting last, that element will come first, that element will come out first. That means last element will come out first. Last element will come out first. Last element which enters into a stack, that will come out last. Last in, first out. Okay, last in, first out. That means it follows a stack, a special data structure where insert and delete operations are performed only at a specific end. At a specific end. This is the rule. Yeah, then next we can write here the order what it is following. The order followed by stack is that what we say, last element. Which last element enters into that? Last element, whatever enters, that is last in will come out first. First out. Last in, first out. That we say here LIFO. LIFO. So that means the rule, the specific rule it follows. What is that specific rule? Means last in, first out. Which element enters last, that element should delete first. Okay, now in that way, if you implement, then we can call it is a stack. Okay, so this for these examples, we have some examples. So in a box, uh, in a box, in a box, if you observe those books, we observe we observe books are a hotel, in a hotel, arranged plates, the plates. So one plate will be on another plate. Okay, so here examples are right. So one plate, for example, think this is a plate. Okay, on this plate one more plate, on this plate one more plate, so one more plate, like that. All these are keep in a single box, like this, in this box. So this is the first plate. Okay, next this is the second plate, third place, fourth plate. Fourth plate enters last. So if you want to take any plate from this, you have to take first this plate, that means which enters last. This came last, so that's why you have to take it first. After then this, after then this, after then this element, like that. If you arrange in a box, if you keep books in this box, uh, books, for example this is a book, so you can keep one more book on this, so we can keep one more book on this. All these are we are keeping in a box, we are keeping in a box. Then how can you take the books, all these books? So one by one, if you want to take whatever the book is on the top, that book you have to take first. So that's why here the last book, last element should come out first. The last element should come out first. After then the next book. After then the next book. This is so. These are the examples about the stack. Okay, now. So what are the operations performed by this stack? Operations performed by stack, performed by stack. Those are: number one, inserting the element. That terminology is pushing the element, push. Okay, yeah. Then next, number two, second operation is pop. Pop means removing the element, or taking out the element, taking out the element. Yeah. Then next, third one, get top. So getting the element, getting the element, this is another operation. Next, fourth operation is empty, whether the stack is empty or not, is empty. The next, fifth one is full. These are the operations we can perform on the stack. Okay, now these operations we can perform on the stack. Okay, we will see one by one. So once observe this. So this is the introduction to stack. In this stack, what is a stack? Definition is: this is a stack is a data structure that provides temporary storage data in such a way that the element stored in last will be retrieved first. This method is also called LIFO. LIFO means last in, first out. So in our real life, the stack of copies or stack of plates. Okay, na? This is the stack. Then next, what are the operations stack in this? Stack is a linear data structure. It is controlled by two operations, push and pop. We said here push and pop are the main operations. So we have three more operations also. Both the operations take place from one end of the stack, usually called top. So we already discussed. At the top, the element will be take place. Okay, the top point to the current top position of the stack. What is the top means? Top means it is the current position. That means where we are inserting the element, where from where we are taking out the elements. Those known, that is known as here stack top. Right. Yeah, the next one, push operation adds an element to the top of the element. Already we said push operation, what it will do, it will add the element. Pop operation, it removes the element from the top. Then these two operations implement LIFO method. These are the two operations, main operations. Okay, so this is how we can implement a stack. Okay, now by using which topic of the C++, we can implement the stack. We can implement the stack in two ways. Number one, using an array. Number two, using a linked list. First, we will see using an array. After then, we will discuss about the linked list. Okay, now? So first, we have to remember what is a stack and what are the operations performed on that. What is the rule to implement that stack? Okay, now? Stack means it is a linear data structure. It can follow the rule last in first out, and operations push, pop, get top, is full, is empty. Okay, now these things. So push operation to add the element or to insert the element into the stack, pop to remove the element from the stack, get top to get the element from the stack, is full whether the stack is full or not. To know that, the next one is empty if the stack is empty or not. Again, those information we can get using those functions. Again, those operations performed by that function. So right now, how to implement a stack using an array? See, at this here you are observing this, we can think this is a stack. Again, a stack nothing but here linear data structure. Linear data structure means first example we saw arrays. Using the array, we can implement the stack. Again, so array can store the elements. But here, see, an array to store the data. So we are taking one array. The next one, an integer type variable usually called top. So we are taking one variable that is a top variable which points to the top of the stack. So it can always points the top element. It always points the top element. Okay, this is the top one more variable. The variable top contains the index number of the top most filled element of the array. That means what this top contains means this index first 0, 1, 2, 3, 4. When we insert the element at the 0th index, then it moves to the first index. Top will move to the first index. When we insert the element into the first index, then top will move to the top will move to the 2. That means second index array. Then next this is top will take a 2. Then next if you insert element into the second index, that means 2 index, then top will move to the third index. Like that top will be always top. Okay, that is inserting the elements. Where we are inserting the elements, deleting the element. That is how to implement a push operation. How to implement a push operation on the stack. So see this thing first, we have to check. We are taking a array. If you want to insert the element into the array, first you need to check whether that stack is empty or not. If it is empty, we can keep the element into that. If it is not empty, then we cannot insert the element into that. Okay, now see first of all we have to remember array is a fixed size collection of elements. Yesterday we said about this. Okay, now so fixed size, that means the array is a fixed size, means a fixed number of elements we can insert into that array. So we are taking here array stack using the array. So that means stack is also fixed size if you use the arrays. Again, if you use the linked list, there is no fixed size. Okay, now but here using the array, it is a fixed size stack. So that's why we have to check whether that stack is full or not, or stack is empty or not. If the stack is empty, then we can insert the element. If the stack is not empty, then it is not possible to insert the element, just it will overflow. Again, that is, see here, initially when the stack is empty, top can have any integer value other than any valid index number of the array. Okay, let top is equal to -1. So if the stack is empty, then a top element, top is a variable, that top variable will take a -1. That means the stack is empty. If the top is -1, then that is a stack is empty. Okay, now then next one, remember these points. Okay, now first thing, top, if the top is -1, if a top is equal to -1, then stack is empty. The first element in the top empty stack goes to the 0th position of the array. Then the top is initialized to value 0. Okay, now when we insert one element into the stack, then top will be increased. When top will be increased, initially top is -1, increased by 1, -1 plus 1, then top value will be 0. Okay, now that means the first index is empty. So we can insert the element into the first index. After this, every push operation increase the top by 1 and inserts new data at the particular position. As arrays are fixed in length, just we discussed, arrays are fixed in length, elements can be inserted beyond the maximum size of the array. So the size of the array, if the size of the array is 10, we can insert the elements, 10 elements into the stack. Pushing data beyond the maximum size of the stack results in data overflow. If you want to insert the 11th element also, then it shows that data overflow. That means we need to check whether it is a full or not. If it is a full, that means if the top is 10, then that is the full. Okay, then it is data overflow. In this way, we can write the push operation. Okay, yeah, then like this. See here, we are taking this is the empty stack. When it is the empty stack, top is equal to -1. Okay, now empty stack top is equal to -1. Okay, now I am inserting one element into this. One element into this. So what is the index? The top index is a 0. Into the 0th element, 0th index, we are inserting the element 10. Then top will be 0. Okay, now so from -1 to 0. Okay, now then I am inserting the element into the first index. Then this is the top. So what is the top here? First, number 1. Top is equal to 1. Top is equal to 1. 20 is inserted. Then next I am inserting second index into second index. So in the second index we are inserting 30. The push 30. 30 element is stored in the second index. Then top will be 2. Then one more element, push 40. 40 is inserting into the third index. Then top is equal to 3. Okay, now then next element, push 50. 50 we are inserting into the top. So top is 4. Top is increased. Top is 4. If you want to insert one more, then what it will show you? That stack is full. It shows that stack is full. Like that, so the elements will be stored by using one variable, that is top. When top is equal to -1, top is stack is full. If the top is equal to maximum size, we can complete array size. If it is array size, then that means the last index. So how many elements are there here? 5 elements are there. 5 elements. Then top will be 5 minus 1. That means the array size is 5. 5 minus 1, size minus 1. If the top is equal to size minus 1, then stack is full. Okay, now remember that top is equal to -1, stack is empty. Top is equal to size -1, then stack is full. Okay, now those two operations, by performing those two operations, we can insert the element into that. Okay, next how to delete the element. So how to pop the element, delete the element. So to delete the element, first the stack must contain an element. If there is no elements, we can't delete the element from the stack. Okay, now that means stack must have at least one element to remove, to perform pop operation. Again, if the stack is empty, we can't perform pop operation. So that's why the pop operation deletes most recently entered item from the stack. So this is the rule. When we are inserting the element, we can insert from the top. When we want to remove the element, also we can remove from the top only. Okay, now that means top means recently entered element. Okay, recently entered element that must be come out first. See, any element, any attempt to delete an element from the empty stack results that data underflow condition. That means if the stack is empty, even we want to perform pop operation, what is the result? The result will be the data underflow. Data underflow. Okay, now any attempt to delete any element from the empty stack. Right. Next, the top contains the index number of the current top position of the stack. Always we are talking about this. What is the top? Top means it contains the top index value. Top index value it contains. Okay. That is each time the pop operation is performed, the top variable decremented by 1. So here, while we are removing the element from the stack, then the top will be decreased. Top will be come down by 1. Okay, that is a push operation and a pop operation. So while performing the push operations, we have to check whether stack is full or not. If it is the full, we can't insert the element. We can't insert the element. Okay, just we have to say data is overflow. Then a pop operation. If you are performing pop operation, we have to check whether stack is empty or not. If it is empty, then we cannot pop the element. That means we cannot remove the element. Okay. So if you are trying to pop the element, even it is empty, then the result is data underflow. Data underflow. Okay. Now these two operations will be done. So this we check about the pop operation. How? Just we insert the elements now. Now, if the top is what is the top? So complete a size of this stack is 5. Top is equal to 5 minus 1, 4. Then top is equal to 4. So that's why stack is full. Okay, now stack is full. So we can stack is full means there are elements. When it contains the elements, we can remove that. Yeah, we pop the element. So we can remove the element from the top only. Then the top will be decreased to 3. Here top is 4. So now the 50 element will be removed. When 50 element removed, then top will come down. When top come down, then top is equal to 3. Then here we are removing 40 also. When 40 is removed, then top will come down by 1. Okay, now top is equal to 2. Then like that, when we are removing the element from the second index also, then top will come to first index. Then we are removing the first index, top will come to 0. When we are removing the zeroth element, zero index element, also top will come to the -1. When top is -1, stack is empty. If you try to pop the element, then it gives the result that is data underflow. Data underflow. So when top is equal to -1, then just we have to get data underflow. There is no elements to pop that. Again, these are the two elements. So how to write the program in the using a stack? This is see include iostream.h, include process.h. We can take a size of the stack, that is 5 elements we want to insert. 5 elements, this is the size. Then we are taking a class stack in a C++ program. Here we are taking a class. This class contains 2 variables. One is for a stack, that is array. Okay, na array. Then next one is a top variable. Top variable, already we know that top will point to the last item pushed into the stack. Always it points the current element index. Okay, that is 2 variables we are inserting, we are declaring here. First variable is the array variable with a size of 5. Second variable is the top. Then we are taking a constructor. So this constructor, when we are starting the stack, then the top must be the -1. When it is a -1, then the stack is empty. That means now stack is created, but there are no elements. Okay, now we have to push the element. So when we want to push the element, the function, this function will perform the push operation. How it is performing? When we want to push the element, first we have to check whether stack is full or not. If the stack is full, we can't insert the element. So how we can check it? See here, if the stack is top is equal to size -1. If the top is equal to size -1, then top is equal to size minus 1 means top is at the top. Again, complete all the elements. When all the elements are filled, we cannot insert one more element. So that's why here just we are giving we are printing one message, stack is full, given item cannot be added when top is equal to size minus 1. Otherwise we can insert the element. If it is a fail, if it is a false, then go to the else part. In the else part we can increase the top plus plus. After increasing the top, then we are inserting element into that. Okay, na? Array top is equal to item. Then how to perform the pop operation? If the top is equal to minus 1, the top value is the minus 1, then stack is empty. We cannot delete the element if top is equal to minus 1. If top is equal to minus 1 is false, then it enters into this. So then what we do, we can take out, so we can print that top element, array of top. We can take that element and just decrease the top minus top minus means it will be decreased by 1. This is the pop operation. Again, if you want to display all the elements, then display function, how we are printing the array values, in the same way we can write the code. For int I is equal to top, from the top to 0. From top to 0, we are iterating the loop and we are printing that. Okay, na? That's now execution starts from the main. We are creating a stack object for this class. We are creating the object here. Okay, na? So we are taking one character variable and data. So infinitive loop enters into the infinitive loop. First it takes the number 1. This is the menu printing. Number 1 push operation. Number 2 is the pop operation. Number 3 is a display operation. Number 4 is a exit operation. So enter the choice 1, 2, 3, 4, whatever we can enter that. So if you enter 1, then it performs a push operation. Again, if enters 1, then push operation. If you enters 2, then pop operation. If you enters 3, then display operation. If you enters 4 or any others, then it enters the exit minus 1. It will come out. Okay, now that is this is the stack implementation using the program. Okay, now so once observe this carefully, the pop operation will check, push operation will check top is equal to minus 1. Pop operation will check top is equal to minus 1. Here top is equal to minus 1 means the stack is empty. Top is equal to size minus 1 means the stack is full. Okay, now this is about the stack in linear data structures using arrays. Using arrays, we are performing the stack. We are implementing the stack. Okay, the next class we will discuss next topic. Okay, in the next class we can discuss next topic. These are the operations we perform. Right. Thank you. Today's class 17 participants. Thank you. If you have any doubts, you can raise the doubts now, if anybody. Any doubts? Great. Thank you. We will stop. We'll meet in the next class on Saturday.